Good evening. I think it's time to start. If you can take your seat, that would be great. Okay, let's start. So good evening and welcome to the IMS Award ceremony. And it's my great pleasure to welcome all to celebrate the remarkable achievement of the contributions and achievements of the individuals who exemplify the highest standard of excellence in our profession. And their work span theory, application, and service, and reflects the depth and the vitality of statistics and data science. And thank you for joining us in honoring today's outstanding recipient of IMS Awards. But before we start, I want to briefly highlight the new initiatives IMS has launched over the past 12 months. And this year, the IMS presents the first Selma and Marvin Zellen Emerging Women Leaders in Data Science Award. And this award was funded by generous donations from the Zellen family and friends, and we thank them for their generosity. And the IMS has also started a new IMS Frontiers in Statistical Machine Learning conference. And this conference will be held annually right after the IMS New Researchers Conference and right before the JSM. And the IMS is a truly international organization. And by our latest count, 45% of members are based in North America, 25% in Asia, 23% in Europe, and 7% in the rest of the world. And to reflect that, this year IMS will launch a new researchers conference held alternately in Europe and in Asia. That's in addition to the very successful new researchers conference held annually right before JSM. In addition, IMS is joining the African International Conference as an official partner. And we will provide $10,000 to support African researchers to attend the conference. And IMS is trying very hard to further outreach regions where it's underrepresented. And now I want to introduce IMS leaders who are sitting in the front row. And first, Michael Kosarak, the past president of IMS. Michael's picture is right there. Second, Richard Samworth, the incoming president-elect. And third is Annie Chu, right there, program secretary. I also want to take this opportunity to thank Michael Kosarak for his outstanding service to IMS. First as IMS president-elect, now he's the outgoing president, past president, and he will step down tomorrow. And I want to thank you by presenting you And also, I want to thank the IMS chairs for the 2025 JSM. It takes a lot of effort to organize the IMS portions of the program. Stefan Weger, program chair, and Zihua Su, the contributed paper chair. I don't know if Stefan is here. You should come up here. So people can see you. Okay, Stefan is there. Thank you very much for your service. Is Zihua here? apparently he's not. Okay. And also before we begin, I also would like to take a moment of silence to remember the members who have passed away in the last year. Tom Kurtz, he was a former president of IMS. Miles Hollander, Jean Lasker, Seamus Maintenis, Wari Mila, Sayan Mukherjee, Boris Razowski, Paul Shaman, who was my colleague, and Bill Strodman. Thank you. And the IMS has many awards that are bestowed on both members and non-members. And this award ceremony tonight is to present those awards that are for service to the profession and our travel awards. In addition to these awards, IMS also have awards given for special lectures. And those awards will be presented immediately before the special lecture itself and not present here today. Now I want to invite Michael to come to the podium.
The Carver Medal was created by the IMS in honor of Harry C. Carver, founding editor of the Annals of Mathematical Statistics and one of the founders of the IMS. The medal is for exceptional service specifically to the IMS. We are presenting both the 2024 and the 2025 medals this year. The recipient of the 2024 Carver Medal is Runzi Lee for exceptional contributions to IMS, especially through his steady service and guidance of the editorial board of the Annals of Statistics as co-editor, and then as editor during a long period of difficult times due to unexpected circumstances. Professor Lee has also made excellent contributions as program chair of joint meetings of the IMS and several different Pacific Rim statistical associations. The recipient of the 2025 Carver Medal is Annie Chu for excellent service to the IMS in several important dimensions, in particular for outstanding contributions to the IMS by serving as committee chairs, IMS Program Secretary, and IMS Executive Committee member, for organizing IMS conferences, including the highly impactful International Conference on Statistics and Data Science series, and for overall broad professional services.
So my task is to introduce the new IMS Fellows. Those who are named IMS Fellows have demonstrated distinction in research in statistics or probability by publication of independent work of merit. Fellows may also be well-established leaders whose contributions to the field of statistics or probability, other than original research, are of equal or greater value, or their work has contributed greatly to the utility and appreciation of these areas. We will be presenting the awards to those available to join us this evening. As your name is called, please approach the podium to receive your award. Jose Blanchet, for outstanding contributions to the IMS stochastics and applied probability communities, for impact on disciplines beyond the IMS community, including the larger Monte Carlo operations research and machine learning communities. Jelena Bradic, for innovative contributions in causal inference, robust machine learning methods, double robustness, for development of inferential methods that do not rely on sparsity in high-dimensional settings, and for exceptional service to the statistical community. Tianqi Kai, for pioneering contributions to translational statistics and developing end-to-end informatics tools for multi-institutional electronic health records data, enabling scalable and reliable research, for fundamental innovations in survival analysis, predictive modeling, precision medicine, and high-dimensional statistical learning, for groundbreaking advancements in integrating statistical and machine learning methods for robust electronic health record analysis, for exceptional mentorship and professional service to the field. One for the family album. Philip A. Ernst, for groundbreaking contributions to exact distribution theory, mathematical finance, optimal stopping, queuing systems, and stochastic control. Nicholas J. Horton, for exceptional scholarly contributions to undergraduate education of statistics and data science, and for highly influential leadership and services in the statistics profession. Chung-Yu Hang, for outstanding contributions to statistical methodology, especially in survival analysis, longitudinal data analysis, recurrent event analysis, panel count data analysis, bias sampling, and the evaluation of vaccine efficacy trials, for excellent service to the profession through mentoring and editorial efforts. Qi Long, for distinguished contributions to advancing statistics and data science, for outstanding leadership in the impactful application of statistics in biomedicine. Brahma Mukherjee, for influential contributions to the statistics of public health, particularly in developing empirical-based methods for case control studies, advancing gene-environment interaction analysis, mediation analysis, and infectious disease research, for dedicated mentorship of students and early career researchers, and for exemplary leadership and service to the profession. Aditya Kumar Ramdas, for pioneering the new subfield of game theoretic statistics based on E-values, confidence sequences, and betting, and for fundamental contributions to post-selection inference and multiple testing, conformal prediction, and statistical machine learning. Aditya, are you here? Seems not. James M. Robbins, for outstanding and sustained contributions to statistical theory and methods for causal inference and semi-parametrics, and for dedication to mentoring young statisticians. Jamie Robbins, are you here? Okay. Alan Murray Sly, for being one of the best probabilists in the world with outstanding impact on the field, having completely settled formidable problems that had challenged and often baffled probabilists, statisticians, and computer scientists for decades. Weijie Su, for groundbreaking advancements in statistical viewpoints on privacy-preserving data analysis, for novel applications of shape-restricted regression to enhance peer review, for fundamental progress in understanding gradient-based optimization methods, and for significant contributions to the theoretical underpinnings of deep learning. The next slides present the new fellows who couldn't join us today. You can read their citations in the bulletin or on our website.
It's truly my great honor to present the first IMS Selma and Marvin Zelen Emerging Women Leaders in Data Science Award. Professor Marvin Zelen was recognized as a leader for his forward-thinking vision, generosity, and nurturing mentorship, guiding 2 generations of researchers. He gained a renown for pioneering data science contributions. His wife, Thelma, was regarded as a driving force behind Professor Zelen's groundbreaking work in data science and biostatistics. This award was created with generous donations from the Zelen family and friends. As I announce the 2025 recipients, please come up and accept your plaque. Irina Gainanova, for her significant contributions to the development of statistical methods for high-dimensional biomedical data. Her innovative matrix models for identifying partially shared signals and Gaussian copula models for mixed data types have advanced the field of statistical methodology. Additionally, her efforts in open access software development, enhancing statistical education, and mentoring a diverse group of junior researchers, coupled with her editorial and leadership roles, reflect her outstanding impact on the statistical community. So for various personal and other reasons, our next 2 awardees unfortunately could not come to receive the awards themselves, but they have mentors and good friends that can receive the award on their behalf. Xu Shi for her groundbreaking intellectual leadership in developing the efficiency theory for negative control and test negative design, significantly advancing methods for bias reduction in observational studies. Her influential work in data curation, harmonization, and analysis of electronic health records has set a high standards for collaborative research in medicine and public health. Additionally, her steadfast contributions to professional societies, exceptional commitment to diversity and inclusion, and thoughtful mentoring of students and trainees highlight her multifaceted leadership in the field. But I will do an AI exchange of the photo later. Yi Zhao for her fundamental contributions to analytical methods and applications in medical imaging, neuroscience, psychiatry, and mental health. Her exceptional work in Bayesian statistical inference and computation for structural and graphical data has driven innovation across multiple disciplines. Furthermore, her dedication to mentorship, professional service, and leadership has made her a role model for the next generation data scientists. Accepting the award on Yi's behalf is one of her mentors, Jian Kang.
Okay, the next award is for the Peter Galvin Hall IMS Early Career Prize Award. And Peter Hall played a significant role throughout, let me see if I have this, yeah. Significant role throughout his professional career in mentoring young colleagues at work and through professional society activities. The purpose of this award is to recognize early career research accomplishments and the research promise in statistics, broadly construed. And 2025, the recipient of the Peter Galvin Hall IMS Early Career Prize Award is given to Professor Chen Chun Shi. Chen Chun Shi, the citation is for groundbreaking contribution to the development of a wide range of statistical methods and advanced tools in reinforcement learning and their applications to healthcare and technological industries. Bridging gaps between statistics and machine learning and combining exciting theory with a practical usefulness. So, Chen Chun.
It's now my pleasure to announce the IMS Hannon Graduate Student Travel Awardees and the IMS New Researcher Travel Awardees. So the purpose of the IMS Hannon Graduate Student Travel Award and New Researcher Travel Awards is to fund travel and registration to attend and possibly present a paper or a poster at any IMS-sponsored or co-sponsored meeting. The following IMS members received awards in 2025. If the award recipient is present tonight, please stand when your name is called. Following tonight's presidential address, we are asking the awardees that are present to meet by the stage for a group picture. Please hold your applause until all awardees are announced. The 2025 Hannon Graduate Student Travel Award recipients are William Beckerman, Soham Bonerjee, Ahit Chakraborty, Elaine Chu, Yizhe Jing, Lorenzo Gilotti, Soham Ghosh, Lin Gui, Jikai Jin, Wenbo Jing, Takua Koriyama, Yi Liu, Ziyi Liu, Tianyi Ma, Xinran Miao, Jinkung Chu, Ziyi Song, Runshe Tang, Bohan Wu, and Hua Li Zhao. And the 2025 IMS New Researcher Travel Award recipients are Jin Hong Du, Larry Han, Jennifer Camp, Subodh Kotakal, Xiang Li, Jing Yuang, Chan Park, Heejun Shin, Yan Sun, Edric Tam, Jiajun Tang, Liu Sha, Han Yan, Yichen Zhang, Yidong Zhou, and Yichen Zhu.
Reminder that I'm shorter than other people. I'd like to now, and I have the privilege to introduce the IMS Presidential Address for 2025. This is Tony Tsai, our president and the 90th president of the Institute of Mathematical Statistics. Actually, how do I forward the slides here? Okay, yeah, next. I wanted to give a little bit of a background of his outstanding contributions and accomplishments. One thing I want to mention is that he started university at 15, and one of his areas of expertise is playing bridge. So that's one I hadn't heard before. He received his PhD in 1996, became Fellow of IMS in 2006, received the COPS President's Award in 2008, was an IMS Medallion Lecturer in 2009, editor of the Annals of Statistics from 2010 to 2012, Vice Dean of the Wharton School from 2017 to 2020, received the Nother Distinguished Scholar Award in 2023, President-elect in 2023, President 2024, many other accomplishments. Next slide. And I haven't listed everything. I just want to give an overview of some of his achievements. Has over 200 publications, with an astonishing H index of 84, one of the highest in all of statistics. His publications are extremely high quality, highly influential. I mentioned he has more than 50 Annals of Statistics papers. His work has been very influential in a number of areas: statistical machine learning, functional data analysis, large-scale inference, non-parametric function estimation, statistical decision theory, applications to genomics, and financial econometrics. One of his papers that I remember reading when it came out is the Interval Estimation for Binomial Proportion, 2001 Statistical Science, has over 4,000 citations. To try to summarize this, I would say that he is really one of the key influences and architects of modern statistical science. He's also a tremendous mentor, mentoring about 37 PhD students, all with stellar careers, including many who now guide PhD students themselves. He's a thoughtful, patient, kind leader, a wonderful human being. He's interested in the success of everyone in the IMS, and it's been a great pleasure to work with him. I now turn the time over to him. He's going to be talking to us about statistics at the crossroads, challenges and opportunities.
Thank you, Michael, for the kind introduction. Let me see, how can I click? This is not connected. Oh, just use that. Okay, that works. Okay, I want to begin to acknowledge the support from the rest of the team. It's a teamwork. And over the last year, I have the privilege to work with Michael, who is the past president, and also Kavita, who is the president-elect. It's a true honor for me to have worked with them, and we have accomplished much. And I also want to acknowledge the contributions from the rest of the executive committee of IMS, Peter Hoff, Annie Chu, and Jiasun Jin. And in my journey along the path of IMS, over the years, I have worked with many people, including wonderful people who work for IMS, but not strictly speaking statisticians. So I also want to acknowledge their contribution. And first and foremost, Elise. Where's Elise? Okay, she's working the next door. And she is IMS. And she is a constant. We are variables. We come and go, and she stays. Yeah, and Patrick Kelly, and we have also wonderful team for IMS journals, Jerry Madison, Christina Matheson, and we also have Tati here, Tati Howell, and Larissa. So we have a strong team of staff, and that makes IMS as a well-run machine. And we are very proud of IMS. Yeah, Alice just walked in. I mentioned you earlier. Yeah, we all thank her for her wonderful contribution to IMS over many, many years. And through my own IMS journey, I have been very fortunate to benefit from the counsel, wisdom, and support from several past presidents. And I want to take this opportunity to acknowledge their influence on me, and also more broadly, their contribution to the rest of the IMS community. And Larry Brown was my PhD advisor. I arrived at Cornell in 1992 as a PhD student. He started that year as IMS president-elect. And that was my first time hearing something called IMS. And when I graduated in 1996, I started my first job at Purdue, and Jim Berger was my mentor. He was the president that year. I still remember the advice he gave me. He gave me two advice, at least two that I remember. One is, don't try to write a book before you get tenured. And two is, you should referee at least 2.5 times the number of papers you submit, because that's the amount of work people refereeing your work. And in 1996, I met two people that has made significant impact on my career. One is Peter Hall. I met him at JSM in Chicago. He gave me two of his wavelength papers to read. And that's the beginning of our collaboration and friendship. The second person is Bernard Silverman. I met him at a conference at Duke in December of 1996. I gave a talk, and he asked me a question. And that question puzzled me for 3 days, and we ended up writing a paper together. I learned tremendously from them, their work ethics, how hard they work, and also how helpful they are to young people. And I learned much from Ian Johnston on wavelengths. And I also have a long-lasting friendship with Jianqing Fang, who is my bridge partner. In 15 years ago, in 2010, I served as co-editors for the Annals, and the other co-editor is Peter Billman. He was IMS president 2 years ago, and we have a lifelong friendship, and I appreciate his support and wisdom tremendously. So I want to take the opportunity to acknowledge their contribution and their influence on me, and also as IMS president. And most of them are my co-authors. I think I wrote papers with Larry, Bernard, Jianqing, Peter, and two Peters. I didn't write papers with Jim Berger or Ian Johnston, but we co-edited a book together, because two of them were my academic brothers. Okay, now I want to talk about something today. It's about statistics, the state of statistics. I think this is a remarkable junction in the history of statistics. If we view statistics as a country, before we have our own territory, and it's an independent country with well-defined boundary, and no one else seemed to be interested in our territory, and we were very happy back then. But ever since the onset of AI, I think we become more anxious. We feel more pressure for a reason. And the explosion of data and computing power and algorithmic advance has opened up new frontiers for statistics and for us to make more broad impact, which is good. But on the other hand, because of the rise of AI and the machine learning, we also feel somewhat insecure, and we should be. The field is moving forward fast, with or without us. And because of that, I think we should think very deeply about how to adapt and how to evolve. And we face unprecedented demand because of the explosion of data. But we also grappling with our identity. What should we be doing? So I think we are at a pivotal moment. I want to discuss specifically 4 points. The first is explosion of data, which everyone knows. And two is machine learning and AI. They're transforming the research landscape. And three is the tensions between foundational theory and practical relevance. And the last one is pressures from impact, speed, and application. So let's start from explosion of data. And everyone knows there's an explosion of data. And human being is going through a rapid process of datafication. The amount of data we generate is growing exponentially. And I think it will keep growing exponentially. And for us as statisticians, the sheer amount of data itself is not a huge problem. I think more problem or more challenge to us is not amount, rather is the other aspect of the new data. One is new type of data. Statisticians historically has focused on the analysis of numerical data. But now there are more and more data are in different forms, like text, image, voice, video, etc. They are not viewed as standard data in statistical literature. Although, of course, we do have people work on those analysis of those type of data before, but as a whole, as a field, we didn't pay enough attention. Another is new structure. In all the textbook, at least I have read, we always imagine there's a one single data source, one single data set waiting for us to analyze. But now there are more and more problems, and data are not in a single place. It's multi-sourced. And more importantly, there's a new mechanism of generating data. It's synthetic data, data that's generated by AI systems, such as large language model. If you look at the types of data, certainly there are many types of synthetic data, be it text, images, videos, or voice. There are lots of them, and you have heard those apps, or you have used those apps. Some of us use them daily, and they generate tremendous amount of new data for us. In some way, it's very good. For example, if we want to train, say, AlphaZero, all we need is let AlphaZero play by itself. And through that, AlphaZero can learn how to play chess and become an expert very quickly. But on the other hand, for many other purposes, AI-generated data can be a problem if we don't treat them carefully. So by some prediction, AI-generated data is expected to exceed human-generated data for the first time next year, 2026. And by 2030, the prediction is AI-generated data may account for more than 80%. And we can easily extrapolate by 2040 or 2050, most of the data generated in the world is by machine, not by human. So the question is why that matters. Data is data. But it turns out it matters tremendously for certain purposes. For example, many machine learning system actually uses AI-generated data to train its own model. So if you treat this AI system as a human being, he sees the world as he sees the world. Because the data is generated by the system itself, it can lead to significant bias, and it reinforces itself. And another thing is, for certain purposes, we do need to know whether the data is generated by machine or generated by human. Think about when you teach a class and students turn in excellent reports. And the student is not as good as before, as you know the person, but the report itself is tremendously excellent. And you have doubts. How can you judge whether the report is written by the student himself or it's by a machine? And there are many other applications where you do want to know whether it's generated by machine or human. And this leads to many questions. For example, how can we tell or how can we test whether a given text, an article, or a given image or video is generated by machine? And two is how to analyze that a data set that's a mixture of human-generated and machine-generated data. And that's something we have never encountered before. And so this, in some way, they're very good because they generate new research problems. In some other ways, they're not as good. And the second point is that ML, or machine learning, and AI are transforming scientific research in a very fundamental way. And we don't need to go any further than looking at the last year's Nobel Prize. Last year's Nobel Prize is groundbreaking. Nobel Prize in chemistry was given to Demis Hassabis. He was a co-founder and CEO of DeepMind. He's a computer scientist. If you ask him, I doubt he would regard himself as a chemist. But he won Nobel Prize in chemistry. Yeah, I actually don't know what the chemists think of him. And the Nobel Prize for physics, one of the winners is Geoffrey Hinton. He is regarded as the godfather of AI, but he's also a computer scientist. I'm not sure if you ask him, he would regard himself as a physicist. But their contribution has no doubt they made fundamental contribution to their respective field. I hope at some point a statistician will win a Nobel Prize. And the third point I want to make is tensions between foundational theory and practice. If you look at the landscape of AI, the well-known methods or tools like deep learning, large language model, transformer, reinforcement learning, transfer learning, federated learning, none of those were first proposed or studied by statisticians. They all come from machine learning or CS community. And somehow, without formal statistical training, those methods, we know they work. Actually, they work very well. And mostly, we don't know why. So machine learning community has come up with a new way of doing research or developing tools for data analysis that's fundamentally different from what we approach the problem. And this also leads to another related question. It's about validation of a method. If we propose a method, what's a good way of justifying the method? For statisticians, we like to prove theorems, statistical optimality, and that will get your paper published in the Annals of Statistics. And to machine learning people, they will argue differently. You have to show me how it works. So their way of justification or validation is to try on some well-known test database or the leaderboard. If you can beat all the existing methods, you are good. If numerically, empirically, it performs poorly, although you have theory, it doesn't work. And traditionally, we look down on those type of empirical validation. But I think more and more they have a point. For a wide range of applications, maybe their method is not universal. Under certain theoretical assumptions, it always work. But for a specific application, it tends to work very well. And partly it's because of our lack of ability to develop foundational theory for all those popular machine learning methods. And so theory lags behind practical development in machine learning and AI. In one way, we should work much harder. We should still have lots of people working on theoretical development with new tools and maybe more powerful tools. But in another way, I think we also need statisticians to develop practical methods that works in practice and can compete with people in CS. And another is the difference in culture. And there's a disconnect between academic incentives. Junior people need to get tenured, so they need to publish papers in top journals if you want to survive in statistics. And we don't give enough credit or emphasis on real-world impact. So we need to bridge rigorous theory with scalable and applied methods. And we need to give more credit to people working on applied problems. If you think about different style or different goals, certainly there's pressure. There are pressures for impact, speed, and application. And before COVID, all my previous students, they went to academia, and they become faculty members elsewhere. But in the last few years, more and more of my students are going to industry, and partly because of compensation, but also partly because of the interesting problems they are working on. They feel that they can make more impact. And in industry, they care about fast deployment and decision-making at scale. They want to build a system that works in a large scale, not on a small test data set. And certainly they also care about return on investment because they are companies. And for researchers, we also face growing expectations of real-world impact and visibility. In terms of publication, we have long-lasting discussion about different styles between statistics and machine learning. In statistics, it's normal to receive the first review in 5-6 months. And in machine learning, it's in a small number of weeks. And I'm not advocating that type of publication process, but I think they do have some points in speeding up the publication process to get the paper published relatively more quickly. And we also face pressure from society about privacy, fairness, and reproducibility, and so on. So our field as a whole is evolving in a very different environment. So we have an identity issue. And we need to ask hard questions. What unites us as statisticians? Why we should insist on doing what we have been doing and without any change? And also in relationship to data science, are we data science, or are we part of data science, or the relationship is not one containing the other? Also, we have somewhat difficult relationship with machine learning. Are we complement to each other, or are we competing with each other? I think probably both are true. And we need to articulate and modernize the value of statistical thinking. But the rise of AI certainly is not bad news. It's very good news to our field. And it opens rich opportunities for statistical thinking to contribute deeply. As I mentioned earlier, how to analyze mixed human and AI-generated data. And that's certainly a new problem. It didn't exist even a few years ago. And also, society asks for more, not just accurate statistical results. They ask for privacy, fairness, and also responsible data sharing. I also mentioned a moment ago that now more and more applications involving data from different sources, multiple sources. And that's a new frontier of research for us to do multi-source learning. And they have different format. It could be federated learning, transfer learning, meta learning, multitask learning, and distributionally robust learning. I think as a whole, we statisticians have something to learn from machine learning people. One thing I think they do better than us is to come up with better names. And I'm in a business school. I learned from my colleague that names matter. And having a good name helps you to sell the product. And also, the rise of AI opens another new frontier for us in terms of research. It's the interplay or trade-off between statistical performance and something that's non-statistical, whether it's privacy, fairness, computational cost, or communication cost. And we used to work very comfortably within one circle, statistics. But now we have to deal with problems or constraints that's traditionally non-statistical. How to understand those problems, I think, pose a lot of technical challenges, but they also have a lot of interesting and important applications. And statistics as a field certainly has its own foundational strength, and we are very good at inference. In comparison, machine learning typically focuses on forecasting, prediction. And we know how to do inference under uncertainty. We know how to quantify uncertainty. And also we get involved in the very beginning, including experimental design. If you work in medical applications or engineering, how to design the experiment is very important. And also we have a unique strength in causal inference. And we also know how to do reproducible research and how to deal with robustness. Those are classical topics in statistics. But I think statistics as a whole also has weakness. And one, I think, significant weakness for us as a group is PR skill or marketing. Before I prepared my slides, I Googled, and you can do the same Googling yourself, top 10 machine learning algorithms. You guess, what's number 1? Linear regression. Number 2, logistic regression. Number 3, trees. Number 4, decision tree. Number 4, random forest. Number 5, support vector machine. Number 6, k-nearest neighbor. Number 7, naive Bayes. And the list goes on. As far as I'm concerned, those top 7 are all statistical methods, and they are developed by statisticians. And somehow, they became among the top 10 or top 7 machine learning algorithms. If we use statistics as a country, I think someone is invading us. And we should behave very strongly to defend our territory. And IMS as an organization is a well-known and wonderful learned society. I think we also have something to do. We must broaden our scope and outreach to engage machine learning community and data science community, and also to support inclusion and across different regions. So we need to promote cross-field collaboration to broaden the definition of statistics. Probably we should treat machine learning as part of statistics. And also, we should reach out to people in CS community and also many scientific communities in biology, medicine, and so on. In another dimension, we should reach out to people in different geographic regions. I mentioned earlier, IMS membership, 45% are based in North America, 25 in Asia, 23 in Europe. Africa has 3%. South America has 2%. I think we should make a genuine effort to reach out to people in those parts of the world. And we should provide support to early career researchers. Also, as I mentioned, in addition to the very successful IMS New Researchers Conference held right before JSM every year, we are going to have another New Researcher Conference to be held between Europe and Asia. And we also need to help ensure that statistics remain central to science and society. And that's also partly related to my earlier statement about weakness of statistics. I think we should do more PR, and we should hire people who can help us to do marketing of statistics. So here's a call for action. I think as a whole, we should compete with CS in shaping data science. And we should stake our claim on our territory. And also in terms of education, I think we should think very hard in modernizing the core curriculum. There's certain textbooks probably need to be updated. Some chapters probably should be skipped to leave time and space for some new content. So we should balance theory, computation, and application. And of course, we will be totally fine to keep doing what we have been doing and keep statistics as it is. But I think the train itself has left the station. It will move forward with or without us. I think it's better for us to evolve and to adapt and to broaden our scope. So the goal is to educate a new generation of statisticians who are fluent in both theory and practice. And we should also broaden our research activity, not within the traditional boundary of statistics, rather in the intersection of classical statistics and AI, such as those problems I mentioned earlier in terms of interactions between statistics and CS. And we also need to expand computational infrastructure and training. In classical statistics, we do care about computation. If you think about, say, a class on theoretical statistics, we do learn MLE. And we spend a lot of effort to prove that MLE under certain conditions, a long list of conditions, that it's efficient, it's asymptotically normal. Only later, we say, oh, sometimes MLE actually is not computable. The objective function is too complicated. And then we start talking about, say, how to get to approximation or something to make it work. So computation is always secondary. But I think in this new age of statistics, it should get more emphasize. And I want to finish with a positive note. Yeah, we have a very good friend in Tom Sargent. According to him, AI is actually statistics, but it uses very gorgeous rhetoric. I think that's related to my claim earlier that machine learning people have a talent of giving new names to old methods, but that belongs to us. And all AI uses statistics to solve problems. If, with effort, we can convince the rest of the world, the society, that AI is equal to statistics, I think we have succeeded as a group. Thank you very much.